We will proceed in pseudo multivariate calculus. Okay, so we are pursuing discussion in pseudo multivariate calculus. Pseudo multivariate calculus. Okay, where someone would ask, what is this pseudo multivariate calculus? What is calculus multivariate pseudo or something like that? Okay, one thing that is pending is line integral and area integral before we wind up. But I have one simple use case to use the pseudo multivariate calculus. Okay, then anyone would ask, what is your use case? Okay, the use case is that what is average speed? Consider that a person is going in a stretch. A person is moving. This point is 0 and this point is 50 kilometer. A person is going by motorbike. A person is going by motorbike. This is 0 kilometer and this is 50 kilometer. Okay, for 10 kilometer, he is driving at 10 kilometer per hour. First 10 kilometers. 10 kilo, I'm sorry, I'm really sorry. Okay, he is going by a motorbike. Now, first, first, he, uh, first 10 seconds, first 10 seconds, he driving at 10 kilometer per hour. I believe it is all right. And then for next 20 seconds, he is driving at 20 kilometer per hour. 10 seconds, 20 seconds. And last 5 seconds, he is driving at 30 kilometer per hour. Makes sense? Means a person is traveling 50 kilometer. First 10 seconds, 10 kilometer per hour. Next 20 seconds, 20 kilometer per hour. Last 5 seconds, 30 kilometer per hour. What is the average speed of a person? Okay, now what is average speed of a person? Now someone would say 10 kilometer per second for 10 seconds. 10 into 10. I'm not talking about total distance. Okay, one simple answer is calculate the total distance. Okay, I said 50 kilometer, origin to 50 kilometer he is going. Leave the distance. Okay, forget it is 50 kilometer. Now it makes sense. First 10 seconds, then next 20 seconds, next 5 seconds. Okay, this is how he is going. Forget it distance is 50 kilometer. Whatever distance comes with the new mathematics, that is the distance he is covering. What is the average speed of a person? Now anyone would say calculate the total distance, divide it by the total time, that is 10 second, 20 second, 30 second, 5 second, 35 second. Total distance by 35 seconds is the average velocity. That is not the way we will pursue in the calculus. What you will pursue in the calculus, please disclose. What we will pursue in the calculus is how we solve. Now there are three reasons. One reason for 10 seconds, another reason for 20 seconds, another reason for 5 seconds. First reason for 10 seconds, 10 kilometer per hour, that is the velocity into time, plus velocity into time. This is called the normalization. How much big the velocity part is. First is velocity into the time, next is velocity into the time, next is velocity into the time. If velocity is high and time is more, this will make a big percentage, big partition in the net computation. Velocity into time, velocity into time, then velocity into time, and then velocity into time. 10 into 10 plus 20 into 20 plus 30 into 5. Divide it by the total time. Velocity, velocity into time, first quadrant. Velocity into time, second quadrant. Velocity into time, third quadrant. Isn't it look like a summation? Summation I to n, I equal to 1 to n quadrant. Summation of these are not available in any of the book. Don't consider that if I don't hear also, then I can refer any of the book. These are not available in any of the book. Pseudo mathematics pseudo multivariate calculus. First quadrant. Now I have a summation. Now summation is I equal to 1. I equal to 1 to I equal to n. I equal to 1 to n. Summation. Velocity into time. Makes sense? Vi into ti. Velocity in the ith. Now we are making partition into a kind of sections. So summation I equal to 1 to n. Summation sign, I believe. Summation sign I equal to 1 to n. I equal to 1 to n. And then after the summation, now v and below bottom I, t below bottom right side I, vi ti. Okay, in the section I, what is velocity and time? Multiply and keep adding for everything. You will get the we will get net velocity into the time. Divide it by summation I equal to 1 to n ti total time. This is average velocity makes. Okay, means what is numerator now? Numerator is velocity into time plus velocity into time plus velocity into time plus velocity into time. Velocity into time, velocity into time, velocity into time, velocity into time. Isn't it a repeated addition? Okay, no, 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 no. It cannot come in repeated addition. Why it cannot come in repeated addition? Repeated addition, if you make, then same item is added many times. 5 plus 5 plus 5 plus 5 plus 5 plus 5. N time is 5 into n. That is repeated addition. 5 plus 6 plus 7 plus 8 plus 9 plus 10. It is not repeated addition. It is addition, but it is not repeated addition. It is repeated addition. I'm not saying 5 plus 6 plus 7 plus 8 plus 9, that is repeated addition. But here, velocity into time is repeated addition. Why it is repeated addition? It is repeated addition in pseudo code. There, pseudo code or abstract code comes into the picture. What is net velocity into the time? First section is velocity 1 into time 1, that is 10 into 10, plus second section velocity into time, velocity 2 into time 2. Third section velocity 3 into time 3. There are three sections only. That is summation of I equal to 1 to n vi ti. This is repeated addition, certainly in abstract fashion. May not be that Vi and Ti are same for all the section, but this is repeated. If I consider all section can be represented through a pseudo code, repeated repeated addition is multiplication. Repeated addition is multiplication. And multiplication is integration. Okay, we are multiplying velocity into time plus velocity into time plus velocity into time plus velocity into time. I can write it as good as velocity into time. It is velocity into time for all the sections. That is nothing but velocity into d of time. Velocity into d of time. Time is from lower, that is 0 second, to the end time. Velocity into time. Hop, hop, hop. I can't tolerate this. This is not possible. Means we started that section 1 is velocity into time. Velocity is different, time is different. Section 2 velocity into time. Velocity is different, time is different. Third section velocity into time. Velocity is different, time is different. How you can say now velocity into dt? Okay, it looks like that t means variation in the t, velocity into for each section of time. Okay, where velocity is function over the time. Makes sense? If I make time as variable, as independent component, velocity will vary depending upon the time, and actually it is like that only. If time is an independent component, and for time 0 to 10, velocity is different. For time 10 to 20, velocity 10 to 30, velocity is different. From time 30 to 5, 30 to 30, 35, velocity is different. Velocity is dependent upon time. Velocity is a function over time. Okay, okay, what is the net result? Net result is velocity into time for first section, velocity into time for second section, velocity into time for third section. Someone can say V1 T1 plus V2 T2 plus V3 T3 plus V4 T4, and then Vn Tn. Tn is the time of a section, not the beginning to end time. In that says summation I equal to 1 to n VITI. VITI, repeated addition, whole will become a multiplication integral calculus, where it is V as a function of time. Now we can say V underscore bracket T, or function over T, that is the velocity, into dt, and T in limit is 0 to any moment T, 0 to 35. Velocity has to be function over time. If I have this, then this will be considered as net addition that we are trying to add, divided by net time, or dt, 0 to 35. That is the net time only. Summation, we made denominator as summation I equal to 1 to n and ti, that is dt integration 0 to n. Okay, means average speed is nothing but integration of velocity into dt. Average speed is nothing but multiplication of velocity into t, and then add it for each section. That is same if you add for each section. Okay, if someone adds velocity for each section, okay, in that sense it becomes v into dt divided by the net time. Integration of the dt is from 0 to whatever the time it is. Okay, that is the concept. Okay, I mean someone can try. If I am wrong or right, that will be visible through any example if I take. Consider that velocity of a person is t. Velocity of a person is t. T means person starts from 0 and his speed is growing as the time is growing. When time is 1 minute, his speed is 1 kilometer per hour. I'm sorry, when time is 1 hour, then his speed is 1 kilometer per hour. When time is 2 hours, then his speed is 2 kilometer per hour. That is velocity equal to t. Okay, what is the average speed? Average speed, if I calculate for any distance 10, consider any distance 10. Okay, I mean, what is the distance that person is traveling? Distance is nothing but velocity. Distance means velocity into time is the distance. Or for the calculus, anyone if asked, if someone has velocity equation, then distance is v dt, that is the distance. If it is t, then t square by 2, that is the distance. T square, same thing. Okay, distance means velocity dt, that is the distance 0 to t. Velocity into time is the distance 0 to t divided by, that is distance, and divided by the total time, that is the average speed. But here average speed we calculated as the addition of different sections. Okay, first section velocity 1 t1, velocity 2 t2, velocity 3 t3. Okay, in that sense if I keep doing like this, then it becomes velocity into dt. Okay, this concept is heavily used in bias theorem in artificial intelligence, machine learning, where we are trying to calculate there is something called evidence. This is what I remember: evidence probability. And there we use this kind of calculus, whatever it is. Now, this is mind blowing. Velocity into time plus velocity into time plus velocity into time plus velocity into time. Doing this repeatedly, it is candidate for repeated addition. That is summation I plus 1, I equal to 1 to n VITI. Repeated addition will become a integral calculus multiplication, and it will become, what is multiplication? It will become multiplication as velocity into time in abstract manner, and then it will become v dt divided by t. Okay, what is average speed? Average speed is velocity into time by time. That is the average speed. Okay, can you give another example? Consider velocity equal to a. Velocity equal to a, and in bracket 1 minus e to the power minus t by b. Make sense? A is a constant, and in bracket 1 minus e to the power minus t by b, where b is constant, a is constant. That is the velocity. If time equal to 0, then velocity is a. If time is growing and time becomes when time is 0, then it becomes a and 1 minus 1, 0. Velocity is 0. There is no velocity at all. When time is infinite, e to the power minus t by b will become 0. In that sense, at the end, velocity is a. If that is the case, then what is average velocity? Okay, now velocity is changing with the time. Okay, then it is v dt, integration of t from 0 to whatever it is, by total time. That is called average velocity. Repeated addition, if we are making repeated addition, then it converted into integral calculus. What is repeated addition? Velocity for the first section and then time. Velocity for the second section for the time. Velocity for the third section and time. Looks like your velocity is dependent upon time. You are multiplying velocity into time. This is what you are trying to do. Velocity is dependent upon time. Looks like that. Then velocity into time. Actually, this is what you are trying to calculate. Yes, yes, yes. This is what I am trying to calculate. Velocity into first section of the time, velocity into time. Velocity into second section of the time, velocity means velocity is changing section by section, and section by section time is changing. Velocity is dependent upon time. Actually, you are trying to do velocity into time. Write it there. Abstract multivariate calculus, you are trying to calculate velocity into time. Time is independent, velocity is dependent. The net is velocity dt. Time is 0 to t. This is the net velocity into time. Divide it by the time, it will come as average velocity. What is average acceleration? What is average acceleration? Consider that equation of acceleration is t. I believe it is all right. What is average acceleration? That is under question mark. What is average acceleration? Average acceleration. Consider that there is a motorbike, and for the 10 second of duration, he is accelerating at 1 meter per second square. For the 10 seconds, he is accelerating at 1 meter per second square. From where? I don't know. He entered frame motorbike, then he started accelerating at 1 meter per second square for 10 seconds. Uh, Next 20 seconds, he started accelerating 2 meter per second square. Next 5 seconds, he started decelerating at 3 meter per second square. What is the average acceleration? What is first acceleration into the time? Next acceleration into the time. Next acceleration into the time. This is the net acceleration into the time. Divided by the total time is the average acceleration. I believe it is all right. This is the concept of average. What is average? First section, what is acceleration into the time? Next section, what is acceleration into the time? Next section, what is acceleration? Here it will be negative because he is decelerating. Acceleration into the time. and divided by the total time. That is the average acceleration. Anyway, what is your acceleration? Acceleration is t. Consider equation is t. Means all the way he is accelerating. Okay. Or acceleration is sine t. Sine t means for 0 to pi by 2 he is accelerating. Pi by 2 to pi he is decelerating. And pi by 2 to 3 pi by 2, pi by 2, I'm sorry, then again he is decelerating. Okay. And 3 pi by 2 to pi, 3 pi by 2 to 2 pi, he is accelerating. Or if I say the person acceleration is t, means as a function of t is independent component and person is keep on accelerating only. What is the average acceleration? What is the first acceleration? Acceleration 1 into time 1, acceleration 2 into time 2, acceleration 3 into time 3. Someone can calculate. First is acceleration is 1 meter per second square for the time duration 10 seconds. Means that is 10. 2 meter per square meter per second square for the time duration 20. That will come as 40. 40 plus 10, 50. And then for the next 5 seconds, 3 meter per second square decelerating minus 15. So it will come as 50 minus 15. That will come as 35. 35 divided by the total time, that is 10 seconds, 20 seconds, 30 seconds, and 5, 30. Oh, 35 only. Okay. 1 meter per second square is the average acceleration. Makes sense? First quadrant 10 seconds, 1 meter per second square he is accelerating. Next 20 second, 20 meter, 2 meter per second square he is accelerating. 20 into 2, 4, 10 into 1, 10. 10 plus 40, 50. For next 5 seconds he decelerating at 3 meter per second square minus 15. 40 plus 10, 50 minus 15, 35. Total time is 10 plus 20, 20 plus 5, 30, 35. 1 meter per second square is the net acceleration. Now if someone is watching it closely, then first 10 second, first 10 second, okay, first first 10 second, now he is acceleration into 10, accelerate a1 into t1 is the first multiplication, summation a2 into t2, summation a3 into t3, that will come as I equal to 1 to n AITI divided by I equal to 1 to n TI. That is average acceleration, the net acceleration into the time by the total time. I mean this is general fundamental, right? General fundamental. Okay, what is general fundamental? Okay, general fundamental is, consider there is a bag, there is a bag, and I am dropping balls in the bag. In first go, I am dropping 3 balls. Second go, I am dropping 5 balls. Third go, I am dropping 1 ball. What is the average I am dropping per iteration? Okay, how much average I am dropping per iteration? First I dropped, oh, I really forgot it. Consider first time I'm dropping 2 balls, then I'm dropping 5 balls, then I'm dropping 1 ball. 5 plus 2 plus 1, 8. In 3, 8 by 3 balls I'm dropping in each act. That is the average, right? How many? One section, 2 balls. One section, 5 balls. One section, 1 ball. Okay, I'm not saying what is total ball, not required. Okay, section by section divided by total section. That is the average. Okay, first he is dropping 2 balls, then he is dropping 5 balls, then he is taking out 1 ball. In third section, he is taking out 1 ball. 2 ball, 5 ball, 7. Taking out 1 ball minus 1. That is 6 by number of section 3. 2 is the, but still 2 ball is dropping in every section. Similarly, what is average acceleration? First acceleration into the time. Okay, average acceleration means per unit of the time we want. Here we wanted per per drop how much balls I am dropping. So total drop and numerator is ball into one drop, ball into one drop, ball into one drop, balls into one drop, balls into one drop, balls into one drop by total drop, because we are asking per drop how much balls we are dropping. Similarly, I am asking for total acceleration, average acceleration. Average acceleration means per unit of a time, what is the acceleration? That is average acceleration. Average acceleration is per unit of the time divided by net time. Net time. I'm not asking per section how much he is doing, per unit of time. So divide by total time, and numerator will come as acceleration into time plus acceleration into time plus acceleration into time by total time. The way I said, balls into one drop plus balls into one drop plus balls into one drop divide by total drop, acceleration into total one into time. It is not one time, acceleration into one time, acceleration into another time, acceleration into another time divided by total time. This is average acceleration. Now it is same as summation I equal to 1 to n, I equal to 1 to n, ai ti divided by summation I equal to 1 to n ti. Okay. Now if someone does it, then numerator, if someone asks what are you trying to do, I am trying to multiply acceleration with the time. Summation acceleration with the time, summation acceleration with the time. Looks like acceleration is dependent upon the time, because every time section your acceleration is varying, means acceleration is dependent upon the time. What you're trying to multiply acceleration into the time, right? At the end you're trying, or repeated addition, what I am saying, then multiply directly. This is called pseudo code, right? Pseudo code, acceleration into time, this is what you want. Okay, acceleration into time, where acceleration is function over time. Instead of a, write f and bracket t, that is your acceleration, into t divided by total time, ft into t. If someone need to multiply two items and one is function over other, then it is a candidate for the, it is candidate for the integration. So it become ft dt, acceleration into dt, integration of the time from one limit to another limit divided by the total time. What is the acceleration? Consider acceleration is t only, then t dt, t squared by 2. 0 to time is, consider time is 35, then 0 to 35. Okay, t square by 2, 0 to 35, whatever comes by total time, that is 35. Okay, that is the average acceleration. Okay, 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 thank you very much. What is the average acceleration when velocity is t? Now you tell me average. There is acceleration, right? Velocity is increasing when time equal to 0. Then velocity is 0. Then velocity is growing the way time is growing. Now tell me average acceleration. Okay, what is acceleration? dv by dt is the acceleration. So acceleration is 1. 1 into dt, integration over 0 to 35 by 35. That is t, that is t, 0 to 35 by 35, that is 35 by 35, 1 only. Up. Average acceleration is 1, yes. See, your velocity is t, dv by dt is 1. 1 is the acceleration, and that is a constant for all the while. When it is going, acceleration is 1 only. So average acceleration is 1 only. Okay, this is called pseudo mathematics. Pseudo mathematics means whatever you are trying to do, write in simple mathematics, multiplication for one section plus multiplication. Then you see what you are trying to do. You're trying to multiply only, write in an algebraic function, ft into t. This is what you are trying to do. Ft into t, that is function over time into t. That is as good as ft dt. Time is 0 to one limit to another limit. That's it. Okay, but if you ask really one, that my acceleration formula is A, and in bracket 1 minus e to the power minus t by b, then what is average acceleration? He will start sweating. I'm really sweating. Okay, it is hot out here. It is not very hot. Last year it was very, very hot. This year it is cold, but in a room kind of scenario it is hot. Otherwise it is not that hot. But still I'm sweating. Probably because of this calculation. Now acceleration is A is a constant in a bracket 1 minus e to the power minus t by b. B is constant, A is constant. Now tell me average acceleration. Acceleration dt, integration over one time to another time divided by the total time is the average acceleration. What is the a 1 minus e to the power minus t by b? I also don't know. A minus a into e to the power minus t by b. First a will become at. Another a to the power a will come out, integration of e to the power minus t by b. Okay, how much it is? Consider minus t by b equal to x. Then dt equal to minus t by b equal to x. Then dt by b equal to dx. dt equal to b into dx. Makes sense? Minus dt equal to x equal to minus t by b. dx equal to minus dt by b. dt equal to minus dx into b. Okay, then the integration of minus a e to the power minus t by b becomes minus a e to the power minus t by b is x now, minus a e to the power x, and here instead of dt it will become minus b into dx. Now it is simple. Integrate and again replace with the t. This is this is now a into t divided by the total time. You will get the average acceleration. Amazing, mind blowing. Start with any problem with normal mathematical computation and write in an abstract fashion what is your mathematical equation. Change the make it in a term of repeated addition or multiplication or division if numerator is dependent upon denominator. What is repeated addition? Can you tell me again? Repeated addition, what I'm trying to say is, consider that you are adding fx into x1, fx into x1 plus fx into x2 plus fx into x3, the way we were doing velocity into time 1. If it is like this, fx into x1 plus fx into x2 plus fx into x3, this is called repeated addition, where independent varying component is looks like x1, x2, x3, that is x only. You're trying to calculate fx into x or fx dx. What are you trying to get? Fx into x. If I say full is, or rather I would say f1 fx1 into x1 plus fx2 into x2 plus fx3 into x3. Okay, if someone is doing like that, then full someone can write fx into x. This is abstract multiplication. Then fx dx, and dx will be one limit to another limit. This is the way we proceed. Okay, we will proceed now. We will take again with our generic length vector that we had devised. That length vector for any curve line, the vector representation of any curve line is I plus dy by dxj, bracket close dx. This is what we had showed, that if I try to find the length of a vector, when we are in procedure to find the length of a curve line, then I can represent this curve line as a vector and calculate the magnitude of the vector. You will get the length of a line, because if I take a vector connecting origin and find x comma y, that is xi plus yj, just calculate the magnitude of xi plus yj, you will get the net length of the line connecting origin and x comma y. Similarly, if I have a line, curve line, that is connecting origin and any point x comma y, where y is a function over x and this is x-axis, this is x-axis. What is the curve length? I have to define. This is abstract mathematics. Abstract mathematics means if I have a straight line and I'm trying to find the length of the line from origin to point x comma y, I represent this as a vector and calculate the magnitude of the vector will give the length of the line. If that is the abstract formula, then that formula will work here also. If I'm connecting a point from origin and this point, another point is x comma y, if I represent this curved line through vector, then calculating the magnitude of vector will give the curve length also. This is what we started as our pseudo multivariate calculus. In that sense, first we will see how we can, whatever approach we are taking, how to calculate the length of the line. The represent this line as a vector and calculate the magnitude of this vector, you will get the length of the line. This is the algorithm. This is the pseudo code. How to find length of the line? Length of the line is represent line as a vector, first step. Second step is calculate the length of the vector. You will get the length of the line. What is the representation in vector? That is xi plus yj. But we see for a curved line, y by x, everywhere it is different. It is not a straight line. Then I have to take out, I have to represent this vector in terms of y by x because y by x is variable here in the curved line. Same thing we will proceed. Xi plus yj. I'll take out x. It becomes I plus y by xj into x. Division will become differentiation. Multiplication will become integration. Now the vector representation of a curved line is I plus y by xj bracket close into x. Calculating this magnitude will give the length of the line. Y by x will become dy by dx. I plus dy by dxj bracket close into dx is the if someone calculate the magnitude of it, it will give the length of the line. Can you corroborate it? Can you prove it? This is my algorithm, our algorithm. This is called pseudo mathematics. In pseudo fashion, we are calculating the length of the line. If I go even simpler, then if I'm trying to calculate a length of a line from origin to point x comma y, then it is Pythagoras theorem is x square plus y square square root. That is same as length of a vector xi plus yj. From there also someone can start. Length of a line from origin to x comma y is x square plus y square square root. That is same as magnitude of a vector xi plus yj. Means if I represent a line section in a vector form and calculate the magnitude, I'll get the length of the line. In that case, that algorithm should work. If I calculate the line in vector form from point origin to point x comma y, if I represent this line in the vector form and calculating the magnitude will give the length of the line. Vector representation of a line is xi plus yj. If I take out x, then I plus y by xj into x. Y by x I took out because y by x is variable in curved line. Now it is full representation. Same thing. Xi plus yj only. This is full representation of a curved line. If I make it calculus way, I plus dy by dx, y by x turned into dy by dx. I plus dy by dx, j bracket goes into dx is representation of this curved line. Means if I calculate the magnitude of this, it will give the length of the curved line. Certainly it will give. Anyway, but idea is can we corroborate? So whatever right now available mathematics is, one is called line integral and one is called surface area integral. Line integral typically comes in the energy calculation, force into displacement, and surface area integral comes into flux calculation. So that we will see, and we will see mind-blowing things that how nice it is to represent that we started with the line vector, and wherever we need line, just to place our line vector and it will start working. But anyway, we will see our approach, how much it is logical in a sense from the available mathematics, that is the current mathematics. Please do not mind supporting us. +91 is the India country code 9483160610 is the telephone number. +91 in the India country code 9483160610 is the telephone number.